Hi, welcome to my video on proving a quadrilateral is a parallelogram. Extra practice number 2. The more problems you do or more proofs you do, hopefully the better you'll understand how to work out the proofs. We have a diagram here and we're given that angle 1 is equal to angle 2. Let's mark that. And we're given that XVWT is a parallelogram. XVWT is a parallelogram. And we have to prove that XYWC is a parallelogram. So let's have a look at the proof first to put it together. So when we start writing it up, won't get lost in it. So angle 1 equals angle 2, and I'm given that XVWT is a parallelogram. So what properties of this parallelogram can I use to help me get these triangles congruent? Because if I want to get XYWC, a parallelogram, then I have to get sides equal or sides parallel, or etc., etc. I don't have any diagonals bisecting. So, and let's see if I can work out these two triangles congruent. Well, I have opposite sides of this parallelogram are equal, so XT is going to equal BW. So I have an angle and a side, so I have to get another angle or another side. So I have a parallelogram here. So if I marked 3 and 4, 5 and 6 on these angles here, notice that in this parallelogram, XVWT, the opposite angles are equal. 3 is equal to 5. Because 3 is equal to 5, then you can get 4 equal to 6 because of supplementary angles and the SAT. So now I have 4 equals 6. So I have these two triangles here congruent by angle, side, angle. And because the triangles are congruent, then I can get XC equals WY. And we now need a pair of, we have these two equal. So can I get parallel lines, or can I get this side equal to this side, and XY equal to CW? Well, we have the triangles congruent. That means that CT would equal VY because of CBCTC in those two triangles. We have a parallelogram right here, XVWT. So we have opposite sides of a parallelogram are equal. So if I add these together and add these two together, then I'll get XY equals CW, and then I'll have two pairs of opposite sides equal. So that's my plan. So here we go. Let's go with number 1. Angle 1 equals angle 2, given. And the only reason I'm not putting this in this step 1 is I want to refer to step 2 later. That's a given. I could have placed the two of these into the first step. Now I'm going to use the properties of a parallelogram. So XT equals WV. Because I have a parallelogram, that means that the opposite sides of parallelogram are equal. Again, this is a parallelogram, so these opposite sides are equal. And also, I have a 3 and 4, 5 and 6. So now I'm going to say that angle 3 is equal to angle 5, because the opposite angles of parallelogram are equal. 3 and 4 are a linear pair, and we have 5 and 6 are a linear pair. The reason is the definition of a linear pair, and that was discussed in the chapter on congruent triangles, on supplementary angles and linear pairs. Look over that unit. Again, it's imperative to have done congruent triangle unit first. So these are linear pairs, and a linear pair is a pair of adjacent angles that forms a straight angle. And as a result, angle 3 is supplementary to angle 4, and angle 5 is supplementary to angle 6, because that's a 5 there. Why did I put 6 there? I don't know. That's a 5. This is a 6, and that's a reason they're supplementary, because there's a straight angle there and a straight angle here, so they're supplementary. And notice we have 3 is equal to 5, 3 is equal to 5. That means angle 4 is equal to angle 6, and that's what we call supplement angle theorem. Again, done in the chapter on congruent, done in the unit on congruent triangles in those videos. So we have angle 4 equals angle 6. So notice now we have 1 equals 2, xt equals wv, and now we have 5 equals 6, so the triangles are congruent. Triangles, we could go with xtc is congruent, xtc wvy, wvy, and the reason is angle, side, angle, angle, side, angle, angle, side, angle, congruency. And as a result of those triangles being congruent, then I have Cx is equal to YW, CPCTC. These two triangles are congruent right here, so these are the corresponding parts. Cx is equal to YW. So we have one pair of sides of the parallelogram equal. So let's see if we can get another pair. So we have, as I said, I have these triangles congruent, so I also have CT and YV are equal. I also have XV and TW equal because they're opposite sides of a parallelogram. If I add them together, then I'll come up with XY equals CW, and then I'll have two sides. So here we go. So I'm going to say that CT equals YV, and that's also CPCTC in the two, that's in the two triangles. So we have XV equals WT, opposite sides of a parallelogram are equal. Remember, XVWT is a parallelogram, so the opposite sides are equal. So that means I can take CT and add on WT, CT and add on WT, and I can take YV and add on XV. That's the addition property of equality, the addition property. Remember, I'm taking CT and adding on WT. I'm taking Y, I said YW, this is YV, just checking. YV and add on XV. So I'm adding these together here. And now, how do I put it together? Well, XY is equal to XV plus VY. So XY is equal to these two segments added. And CW is equal to CT plus TW. So this segment is equal to the sum of those two. And the reason is that's the segment addition property or postulate. And as a result, notice we have these two right here are right here. These two are right here. There they are. And that means that XW is equal to CW. If XW equals those two, and if XY equals these two, and CW equals those two are here and here. There they are. Those two are in here. So they're XY equals CW by transitive property of equality. So now we have XCX. So now we have a parallelogram. XYWC is a parallelogram. And the reason is we have two pairs of opposite sides equal. And that's in, let's put that right here. That's in number 9, which is CX equals right here, and it's in number 14. So look at 9 and 14. That's the two pairs of sides that are equal. Okay, that's one proof. Notice the proofs in quadrilaterals can be long. You got to be very careful in working them out, put them all together. And I made up 3 proofs that are going to challenge you. And again, if you want, you can pause the video and work these proofs out beforehand. But you keep looking around and trying. Let's look at number 2. We're given that BO equals CO. We're given that HO equals TO. Let's mark them so I can see. And we're given that B is the midpoint of MCs. So B is the midpoint of MC. That makes BM equal to BC. It says that C is the midpoint of BA. C is the midpoint of BA. So that makes BC equal to CA. So if B is the midpoint of MC and C is the midpoint of BA, then these are all equal. That means that MB is equal to CA. They're all equal because of the midpoints. And we have perpendiculars. MC is perpendicular to MA, so that's a perpendicular there. And that's a perpendicular there that's given. So HM is perpendicular to MA. And TA is perpendicular to MA, so they're perpendiculars. So with all that information, we have to prove that MATH is a parallelogram. So we have to put it all together. Why did we say that these were equal? Well, because they're equal. Notice I have sides. So if I say 1 and 2, that means I can get the triangles congruent by SAS. And then I need to get over to the opposite sides of a parallelogram or parallel lines. So I'm going to use their parts. That gives me triangles are congruent here. That gives me that BH is equal to CT. Corresponding parts of congruent triangles. So now I'm getting into this triangle here and this one. Notice I got perpendiculars here, which means I have right angles, etc. And now I have midpoints. Again, if we look at it, that's the midpoint of MC, so these are equal. And that's C is the midpoint of BA, so these are equal. So it ends up to be that MB is going to equal CA because of those midpoints. So now I can have these two triangles congruent, but I can't say M equals A, because if I mark this one, I'll have an ASS, and you can't use an ASS in a proof. And you can't use an you can't use in a proof, you can't use ASS, or you can't use AAA. So instead of saying these M is equal to A because they're perpendicular, they're right angles, we have to go with an HL. And triangles are going to be congruent, therefore I can have HM equal to TA. And can I get these parallel to each other? Well, back in the congruent triangles, we did a couple of proofs on parallel lines. If two lines are perpendicular, these HM and TA are both perpendicular to MA. Therefore, because they're both perpendicular to MA, that means that MH is parallel to parallel to AT. So now I have them equal because of the congruent triangles. I have them parallel because they're both perpendicular. And that means I have one pair of opposite sides equal and parallel. So, proof is done. Here we go. Let's have a look at it. So, BO equals CO and HO equals TO given. And we have angle 1 equals angle 2 as a given. So now we have enough information to have the triangles congruent. Triangles BOH, and you have to match up the correct. So BOH goes with COT. And the reason is side, angle, side. There's the two sides and there's the angle in between, so it's a side, angle, side congruency. And as a result of that, we have BH is equal to CT, and it's CPCTC, corresponding parts of congruent triangles congruent. And number 5, we have B is the midpoint of MC, and we have C is the midpoint of BA. Putting both of these in the same statement, and that's a given. So as a result of the midpoints, that means that MB equals BC, MB equals BC, and BC, because C is the midpoint, BC is equal to CA, and that's the definition of a midpoint. We got a midpoint, then you got the two parts of the segments equal, and notice that we got BC here twice, so that means MB is equal to CA by transitive. MB is equal to BC, BC is equal to CA, so MB is equal to CA by transitive property. And that means we can't say that we have this side right here, this one right here equals this one. So MB equals CA. So if I say M equals A, then I'll have an ASS. I can't do it. So what I have to do is say that because they're perpendicular, angle M and angle A are right angles. That's the definition of perpendicular lines. Perpendicular lines form right angles. And because we have right angles, that means that triangle HMB and triangle TAC are right triangles. So because that's a right angle, HMB is a right triangle, and because that's a right angle, TAC is a right triangle. And because we have right angles, that's the definition of a right triangle. And as a result, now we have two triangles. Two triangles are congruent. HMB and TAC are congruent by what we call the hypotenuse leg. This is the hypotenuse of the right triangle opposite the right angle. That's the hypotenuse of this right triangle opposite the right angle. The two hypotenuses, which represents the H, and MB and CA are the legs. So the two triangles are congruent by HL, hypotenuse leg. And that means we have MH is equal to AT, and that's CPCTC. And now I have this side marked with 5 strokes is equal to this one. I got 4 strokes here, so that's 5 strokes. 1, 2, 3, 4. Now, what I have these equal. So if I can get these parallel, but I know back in congruent triangles, there's on some videos, I said that MH is parallel to AT, and the reason that if two segments are perpendicular to the same segment, then the segments are parallel. In other words, MH is perpendicular to MA, TA is perpendicular to MA, therefore they're parallel to each other. And that's a proof that I did in the previous videos on congruent triangles. It's important to look at the congruent triangle unit. And so as a result, notice I have in number 11 and in number 12, I have MATH is a parallelogram because we have one pair of opposite sides equal and parallel. So we have one pair of opposite sides equal and parallel. We have a parallelogram. Again, proof is done. Hopefully it makes sense. But you have to look over proof very, very carefully, especially when you have more triangles in the proof and etc. And we have one more to do to end off the this video. Notice the diagram, many triangles, and notice I given that MATH is a parallelogram. MATH is a parallelogram. Angle 1 is equal to angle 2. I want to prove that BACH is a parallelogram. BACH is a parallelogram. So this is the parallelogram given, and we got to prove that this one, you have to prove that this one is a parallelogram. So we have to use information from this parallelogram to get into the triangles, make the triangles congruent, and then use that information from the triangles to get this a parallelogram. So one thing I noticed that MATH is a parallelogram. That makes this line parallel to this one. At the same time, that's a parallelogram with these sides parallel. That's a part of making BA parallel to HC. So I have these two parallel. So that means if I have these two parallel, BA and HC, because of this parallel, if I can get these two parallel, then I'll have it. Or if I can get BA equals HC, then I'll have one pair of sides parallel and equal. Or if I can get this one, BH parallel to CA, then I'll have two pairs of opposite sides parallel, given the parallelogram. So here we go. Let's go with MATH is a parallelogram. And as a result of that parallelogram, right here, that means that I have MH is equal to TA. That's because the opposite sides of a parallelogram are equal. So here's the parallelogram. So MH equals AT. Now I have, also, based on that, I have MH parallel to TA. That's by the definition of a parallelogram. So if this is a parallelogram, then that means that this side is parallel to this side. Opposite sides are parallel. And because because these are parallel, then I'm going to put 3 and 4 right here. If I put 3 and 4 in, then angle 3 is equal to angle 4, and that's because of the PLT and their alternate interior angles are equal. So I have, note, I have 1 equals 2, I have these two sides equal. I have 3 is equal to 4, so I have enough information to say that the triangles are congruent. What triangles? Well, we could say E, M, H is congruent to F, T, A. Those two triangles are congruent by angle, side, angle. Angle, side, angle. ASA congruency. And as a result of those triangles, then I'm going to name this one 5, 6, 7, and 8. The reason is because these triangles are congruent, then I have angle 5 is equal to angle 8. Angle 5 is equal to angle 8. CPCTC. These two triangles, EMH, are congruent to FTA. 5 equals 6. 5 equals 8. So angle 5 is equal to angle 8. So if you notice that angle 5 is equal to angle 6 and angle 7 is equal to angle 8 by VOAT. These are two lines intersecting so the vertically opposite angles are equal. Here's two lines or segments intersecting, so these are vertically opposite angles equal. So we have 5 equals 8, 5 equals 6, 7 equals 8. So 5 is equal to 8. There they are there. 5 is equal to 8. That means that 6 is equal to 7 by transitive property more than once. So if 6 is equal to 7, that means, if you notice, that these are alternate interior angles. So that means that BH is parallel to, almost didn't see it then, BH, because 6 equals 7 alternate interior, BH is parallel to CA, and that's because of converse of the PLT, that's alternate interior angles equal, which means if I have the alternate interior angles of 6 and 7 equal, these lines are parallel. And notice I have, that's a TA right there. I have MA. Do I have MA? Okay. I have them equal. Okay. What we have is, remember we said that, now I got to say that MA is parallel to HT. Definition of a parallelogram. That means, if you want to put in brackets, that's same as saying that BA is parallel to HC. Because BA is parallel, because MA is a part of this parallelogram, right here, MATH, if I say MA is parallel to HT, that's the same as saying that BA is parallel to HC. So now I have BH is parallel right here. I have BH is parallel to CA. I have BA parallel to HC, and that means that BACH is a parallelogram because of two pairs of opposite sides are parallel, or we could say definition of parallelogram, because a parallelogram has two pairs of opposite sides parallel. So very tricky. For a second there, just looking to see what I was, and I said I got these parallel, so I said I needed another pair, and that's this one. MA is parallel to HC, so that gave me BA parallel to, so MA parallel to HT, so that gave me BA parallel to HC, understood to be that. So I have two pairs of opposite sides parallel. And again, the proofs are a little bit long, but notice the reasoning, and notice you have to think the proofs through, thoroughly think them through. And if you can't get them when you look at them, you keep looking around, and finally it'll hit. Oh yeah, here's how you do the proof. And if you like my video, click on the like button, subscribe button. Visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.